All right, let's take a look at some examples with rationalizing the denominator. So this is page 298, example number 4. So if I take a look at the first one, it's 1 over root 10. It's a denominator that I want to rationalize, so I'm going to multiply both numerator and denominator by root 10. So the numerator will become just root 10, and the denominator will become root 100. Now that will always give you a perfect square. So it was 10 times 10, so the square root of 100 is just 10 again. And then the numerator still is root 10, which is okay. We don't really worry about if the numerator has a radical number or not. It's a denominator that we want to rationalize. Once you get to this point, you try to see if you can reduce this any further. I can't, even though the numbers look same. One is a radical, one is a whole number. So that's the final answer. In part B, the problem part is right here. That's the one that we don't want, the root 6. So what you do is you multiply both the numerator and denominator by root 6. What will that end up giving us? So 20 times 6 will give me root 120. Denominator will give me 2 times root 36. Okay. 120 I can reduce by going root 4 root 30, and then if I simplify this, root 4 will give me a 2. Can't simplify root 30 anymore, so that's just root 30, and then there's 2 still there. Root 36 will give me a 6. So again, no more radical numbers. If you simplify this any further, we know that our coefficients can be reduced further. So that will just give you 1 root 30. You don't need to write the 1 over 6. If you see it written as 1/6 root 30, that is okay as well. It means the same thing. Okay, so the next example, even though they're written as one common radical, we can write them as two separate ones. And again, the problem here is root 5. So you multiply both of them by root 5. The top number will end up becoming root 90 over root 25, which will become root 9, root 10, root 25. And root 9 will give me 3, root 10, and root 25 will give me a 5. You should always get that number that you multiplied with when you simplify this, because you created that perfect square root. In this case scenario, 3 and 5 don't reduce any further, and 5 and 10 cannot reduce because one's radical, one's a whole number. So that's my final answer. So whether you write it 3 root 10 over 5, or you write that whole numbers as a fraction and then just write 2 root 10 separately, same thing.